flight. Okay, engine stop. APA at a descent. Mode control, both auto, descent, engine command override off. Engine arm off. 13 is in.
We copy you down, Eagle.
Houston, Tranquility Base here. The Eagle has landed.
Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
And we're getting a picture on the TV. There's a great deal of contrast in it, and currently it's upside down on our monitor, but we can make out a fair amount of detail. Okay, Neil, we can see you coming down the ladder now.
Sunday, July 20th, 1969. Around the world, nearly 1 billion people watched this moment on television as the first man from Earth prepared to set foot upon the moon.
At the foot of the ladder, the LEM footbeds are only depressed in the surface about 1 or 2 inches, although the surface appears to be very, very fine-grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
All that we have accomplished in space, all that we may accomplish in days and years to come, we stand ready to share for the benefit of all mankind.
As we explore the reaches of space, let us go to the new worlds together, not as new worlds to be conquered, but as a new adventure to be shared.
Since the earliest time, man has imagined this moment, the moment when his fellow man would make the first journey to the moon. Now the time had come. In the 6th decade of the 20th century, the ancient dream was to become a reality. The flight of Apollo 11 was the culmination of many years of planning, working, building, and testing. Thousands of people had contributed toward this day of accomplishment. The great Saturn V rocket and the complex Apollo spacecraft had been assembled together and moved to the launch pad. The equipment and techniques and personnel had been proved in earlier missions, and now they were ready. The astronauts chosen for this mission had flown it many times in ground-based simulators. They had all been in space before. They had trained carefully and well, and now they too were ready. Astronaut Michael Collins would pilot the Apollo Command Module. Astronaut Edwin Aldrin, Jr. would pilot the Lunar Module. And astronaut Neil Armstrong would serve as mission commander. Armstrong would be the first man to step upon the moon. July 16th, the day had come. The moon awaited. The men rose early, ate breakfast, and dressed in their spacesuits. Other astronauts had made this journey to the launch pad, but never with such anticipation. 9:32 a.m., July 16th. 3 hours later, the Apollo command module moves forward to extract the lunar module from the third stage of the launch vehicle. Both are moving at more than 17,000 miles an hour. Docked together, they will sail 250,000 miles across the sea of space and into orbit around the Earth's nearest neighbor.
Oh, loud and clear now, Mike, and we understand that you are docked.
During the 3-day journey to the moon, the astronauts kept busy. Checklists, navigation and observation, housekeeping. They must work in a weightless environment, keeping their spacecraft and themselves in good condition. Data must be collected and reported. Experiments must be performed, including photography both inside and outside the spacecraft. Because of the film speed, these actions appear faster than they actually were. July 19th. Apollo 11 slows down and goes into orbit around the moon. The bright blue planet of Earth now lies 238,000 miles beyond the lunar horizon. Astronauts Armstrong and Aldrin, now in the lunar module, separate from the command module. Astronaut Collins remains behind. Preparation for the lunar module descent to the moon now begins. The command module assumes the new name, Columbia. The lunar module will be called the Eagle. From Columbia, Michael Collins' camera sees bright rays of the sun reflecting patterns of color from the surface of the Eagle. In this strange metallic bird rides the ancient and endless dream of all mankind. The command pilot can see detail which his camera cannot record. The 4 landing pads of the lunar module are fully extended and locked in place. The Eagle is poised and prepared for its descent to the lunar surface. The moon landing craft rocket engine fires to slow it down and to place it on the pathway to the landing site in the Sea of Tranquility. There is tension and caution as the Eagle flies lower. Warning lights blink on as the computer tries to keep up with the demand for control data, but the status remains go.
Eagle, we got you now. It's looking good, over.
Roger, copy.
Eagle, Houston, after yaw around, angled S-band pitch, -9er, yaw, +18. Roger, you're a go to continue power descent. You're a go to continue power descent.
Altitude now 21,000 feet, still looking very good. Velocity down now to 1,200 feet per second.
You're looking great to us, Eagle.
Give us a reading on the 1202 program alarm.
Roger, we got you. We're going at alarm.
Good radar data. We're now in the approach phase, everything looking good. Altitude 4,200.
Houston, you're a go for landing, over.
Roger, understand. Go for landing. 3,000 feet. Program
Copy.
alarm.
Altitude 1,600. 1,400 feet, still looking very good.
700 feet, 21 down. 33 degrees. 100 feet down at 19. 1201. 1201.
Roger, 1201 alarm. We're go. Same type. We're go.
Altitude, velocity, light. 3.5 down. 220 feet. 15 forward. 11 forward, coming down nicely. 200 feet. 4.5 down. 5.5 down.
60 seconds.
Lights on. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 4 forward. 4 forward. Drift into the right a little. That's okay. Contact light. Okay, engine stop.
We copy you down, Eagle.
Tranquility Base here. The Eagle has landed.
Through the window of the Eagle, Armstrong and Aldrin see what no human eyes have ever seen before. Their spacecraft casts a long shadow across the undisturbed dust of centuries. Seven hours after landing, after careful preparations for later ascent were completed, Armstrong opens the Eagle hatch and begins his climb down to the surface. The first footsteps on this strange new world must be taken cautiously. The moon has only 1/6 the gravity of Earth. The nature of its surface was still unknown.
I'm going to step off the limb now. That's one small step for man, one giant leap for mankind.
Once on the surface, Armstrong scoops up a small sample of lunar dust and rock, precaution against the possibility of an emergency takeoff. According to plan, astronaut Aldrin now descends from the Eagle. He and his equipment would weigh 383 pounds on Earth. Here, they weigh about 66 pounds. For a brief moment, the first men on the moon stand and look at the stark, lonely landscape around them, an experience which no one before them can share. But there is much to be done in the limited time which they can stay on this airless, cloudless satellite of Earth. This sheet of metal foil traps and holds particles from the sun, the so-called solar wind, or barrage of solar energy, which constantly strikes the moon's surface. Results of this experiment will be taken back to Earth to reveal new secrets to anxious scientists. An American flag is left behind on the moon, together with medals honoring American and Soviet spacemen who lost their lives in earlier space tests, and a small disc carrying messages of goodwill from 73 nations on Earth. A plaque on the lunar module reads, Here, men from the planet Earth first set foot upon the moon, July 1969 A.D. We came in peace for all mankind. Through a specially made television camera, viewers in many nations on Earth were able to watch the astronauts as they walked and worked on the moon. Despite the bulky spacesuits and the backpacks containing oxygen, temperature control, and communications equipment, the Apollo 11 crew found they could move easily about the surface. Because there is no wind or rain on the moon, these footprints will remain for centuries. In addition to collecting rock and soil samples, the explorers leave behind a seismometer. This highly sensitive device would send back valuable information on external meteoroid impacts, as well as internal lunar movements. A 100-prism laser reflector would help man to measure the exact distance from Earth to Moon to an accuracy of 6 inches. These were the first of many experiments which will be taken to the Moon to provide man continuing and increasing knowledge about the Moon and the vastness of space beyond. After 2 hours and 31 minutes, the first lunar explorers had completed their research on the Moon. A night of rest in the lunar module, countdown preparations, and they were ready to come home.
Tranquility Base, Houston. Guidance recommendation is pings, and you're cleared for takeoff.
Roger, understand. We're number 1 on the runway. 7, 6, 5, port stage, engine arm ascent. Shadow, beautiful. Very smooth. Very quiet ride. There's that one crater on there.
Thousand feet high, 80 feet per second vertical rise.
Eagle Houston, you're looking good at 2. Ping, zags, and midspin all agree.
I'm going right down US 1.
Eagle Houston, going right down the track. Everything's great.
Horizontal velocity approaching 2,500 feet per second.
Roger.
Some 120 miles to go until insertion.
July 21st. The Eagle and its 2-man crew lifted off the Moon perfectly and climbed slowly to rendezvous and dock with the mothership, Columbia. While Armstrong and Aldrin explored the Moon, astronaut Collins had kept a long and lonely vigil in the Columbia. The approaching Eagle was a welcome sight. Later, the 3 men would share their reflections on this adventure with the world.
I believe that from the early space flights, we demonstrated a potential to carry out this type of a mission. And again, it was a question of time until this would be accomplished.
I think it's a technical triumph for this country to have said what it was going to do a number of years ago, and then, by golly, do it.
The relative ease with which we were able to carry out our mission, which, of course, came after a very efficient and a logical sequence of flights, I think that this demonstrated that we were certainly on the right track when we took this commitment to go to the moon.
I just see it as a beginning of a new age.
Once again, the bright blue planet of Earth rises over the lunar horizon. For those who had witnessed man's landing in the Sea of Tranquility, the moon would never again appear quite the same. July 24th, dawn in the Pacific. Apollo blazes across the heavens, coming back to Earth at 25,000 miles an hour. President Richard Nixon, who had talked with the astronauts by telephone while they were on the moon, was waiting aboard the recovery carrier to welcome the returning voyagers. The president later expressed the nation's response to this historic mission.
Some way, when those two Americans stepped on the moon, the people of this world were brought closer together. That it is that spirit, the spirit of Apollo, that America can now help to bring to our relations with other nations. The spirit of Apollo transcends geographical barriers and political differences. It can bring the people of the world together in peace.
To protect against any possible lunar contamination, the astronauts put on airtight special garments before coming aboard the rescue ship. They transferred directly from the helicopter to a mobile quarantine van, in which they would be flown back to the Manned Spacecraft Center in Houston, Texas. July 27th. The journey was ended. They were home again. Ahead lay 3 weeks of isolation, medical tests, and mission debriefings. Then visits to major cities of America and abroad. The details of their unique mission would be relived and remembered so that others might learn what they had learned, and that future travelers in space might build upon their experience. The rock and soil samples brought back would be examined and analyzed by scientists in many lands. They would reveal new insights into the origin and the age and the composition of the moon, and perhaps new knowledge of the Earth as well. Already experiments left on the moon were sending back revealing new information. The mission was successfully completed. The Eagle had landed the first men on the moon, and Columbia had returned them safely to Earth. Wherever man journeys tomorrow across the ocean of our universe, history will remind him that Apollo 11 was mankind's first encounter with a new world.
N.A.S.A. while it's playing the themes of 2001.
April 13th, 1970. The mood could only be described as relaxed. Apollo 13, man's 5th lunar mission. The 3rd, scheduled to land on the moon, continued its tranquil coast.
This is the crew of Apollo 13, wishing everybody there a nice evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening in Odyssey. Good night.
13, we've got one more item for you when you get a chance. We'd like you to stir up your cryo tanks. In addition, have Shaft and Trunnion for a look at the Comet Bennett if you need it.
Okay, stand by. Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Yes, Houston, we've had a problem. We've had a main B bus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
And we had a pretty large bang associated with the caution and warning there. And as I recall, main B was the one that had a amp spike on it once before. In the interim here, we're starting to go ahead and button up the tunnel again.
April 11th, 1970, launch day. The crew of Apollo 13. Jim Lovell, commander and veteran of 3 previous missions. He had orbited the moon Christmas 1968 on Apollo 8. Fred Hayes, his first time up, lunar module pilot. Jack Swigert, command module pilot. 3 days ago, he was on the backup crew. Now he replaced Ken Mattingly. Mattingly had been dropped from the mission because he had been exposed to German measles. He would watch the launch from Houston's mission control.
Auto sequence initiated, flight.
Roger.
Flight booster.
Go. S4B pre-press complete. Roger.
Flight booster. S1C pre-press complete. We're on internal power and we're go.
Roger. How's it look, Econ? You got your space?
Looks good, flight.
Okay. MCC record us to flight speed.
Ignition, flight.
Roger. Roger.
Clock start, flight.
Roger.
Thrusters go, all engines.
Roger. Okay, final, how's it look?
Looks good here, flight. Good agreement.
Okay, booster, how do you look?
S1C looks good, flight.
Okay, Capcom, we go. You on the ground? Okay, we'll go at 1, Capcom.
Get relieving flight.
Roger. Booster, how do you look?
We look good, flight. We'll go.
Okay, start up.
We're go, flight. Looks good here.
Guys, how's it look?
Good, flight.
Okay, Econ, GNC.
Looks good, flight. Looks good, flight.
Okay, Surgeon.
Looks fine. Through max Q and we'll go, flight.
Roger, Booster. And go for staging, Capcom.
Confirm and board out, flight.
Roger.
Staging, flight.
Roger.
Flight 5, trajectory confirmed, staging.
Roger.
Flight booster, then board out was way early.
Okay.
Flight confirmed, number 5 engine down.
Roger. Booster, you don't see any problem with that, though, do you?
Negative, not right now, flight. All the other engines are go.
The next step in the routine of lunar flight was to burn out of Earth orbit toward the moon, then pull free of the third stage and dock with the lunar module Aquarius. At the controls of the command module Odyssey, Jack Swigert.
We're hard dock to Houston. Roger, understand hard dock. Good deal.
They pulled Aquarius away from the Saturn third stage, the S-4B.
Okay, I can see the S-4B now out the hatch window.
Odyssey and Aquarius moved away from Earth toward the moon.
Okay, Houston, we've had a problem here.
5 guidance.
Go, guidance.
We've had a hardware restart. I don't know what it was.
Okay. Houston, we've had a problem. We've had a main B bus undervolt. You see an AC bus undervolt there, guidance? Or, ECOM?
Negative, flight.
I believe the crew reported it. We got a main B undervolt.
We may have had an instrumentation problem, flight.
Roger. And we had a pretty large bang associated with the caution and warning there.
The sensation I had, that I had felt a vibration accompanying the bang, not a large vibration or shudder.
Is there any kind of leads we can give them? Are we looking at instrumentation, or we got a real problem, or what?
We're reading 0 N2 pressure in fuel cell 1 and 13 PSI on fuel cell 3 O2 pressure.
Okay, Barrett, what do you want to do? Open circuit fuel cell 1 and 3?
That's firm flight.
Shut down the reactance valve, and I asked for reconfirmation, since when you do that, it's sort of irreversible. If you shut one of these things down, they only can be restarted from ground support equipment.
Yeah, that's because of AC, and it looks to me, looking out the hatch, that we are venting something. We are venting something out into space. Okay, let's everybody think of the kind of things we'd be venting. GNC, you got anything that looks abnormal in your system? Negative, flight. How about you, Ecom? You see anything that, with the instrumentation you got, that could be venting?
That's a firm flight. Let me look at the system flight as far as the venting is concerned.
Okay, let's start scanning.
Here is a bulletin from ABC News. The Apollo 13 spacecraft has had a serious power supply malfunction that could cause the lunar landing mission to be terminated early.
I assume you've called in your backup ECOMs?
Flight, say again?
Have you called in your backup ECOMs now? See if we can get some more brain power in this
We
thing?
got one here.
Roger.
At the moment, the astronauts are continuing to try to isolate their trouble. The late report says the spacecraft now is operating on battery power alone. All unnecessary equipment is being turned off.
Okay, now let's everybody keep cool. We got LEM still attached. The LEM spacecraft's good, so if we need to get back home, we got a LEM to do a good portion of it with. Okay, let's make sure that we don't do anything that's going to blow our CSM electrical power with the batteries, or that will cause us to lose the main or the fuel cell number 2. Okay, we want to keep the O2 and that kind of stuff working. We'd like to have RCS, but we got the command module system, so we're in good shape if we need to get home. Let's solve the problem, but let's not make it any worse by guessing.
My concern was increasing all the time. It went from, I wonder what this is going to do to the landing, to I wonder if we can get back home again.
Okay, I'm coming back to you.
Flight.
Go ahead.
I think the best thing we can do right now is start a power down.
Right about then, it was quite apparent to me that it was just a question of time that the command module was going to be dead.
You don't want to get fuel cell pumps off, do you?
We can do that on fuel cell number 1 flight.
Okay, well, let's make sure we don't blow the whole mission. Well, the thing that concerns me is throwing equipment. We had a problem. We don't know the cause of the problem.
Flight, I've got a feeling we've lost 2 fuel cells. I hate to put it that way, but I don't know why we've lost them. It doesn't all tag up.
Network from Flight.
Flight network.
Bring me up another computer in the RTCC, will you?
We got one machine on the RTCC, and we got dual CPs downstairs.
Okay, I want another machine up in the RTCC, and I want a bunch of guys capable of running D-logs down there.
Roger that.
What all this means is only speculation at this point. First, though there has been some tumbling or rotation of the spacecraft, the astronauts do not appear to be in any immediate danger.
I'll tell you what, GNC, can you get somebody in the back room to try to figure out what the equivalent delta V is we're getting, so that we can see if we can backtrack to see if we can figure out what's venting.
Roger, we'll give it a try, Flight.
Okay.
When I looked up and saw both oxygen pressures, one absolutely zero and the other one going down, it dawned on me, and I'm sure Jack and Fred about the same time, that we were indeed in serious trouble. The only way to survive the situation was to transfer